cryptography. I'm just going to dance through it and move on. But really, the key here is not so much what's the encryption algorithm that you're using, but really how you manage keys. One thing we've found is that the problem we're trying to solve, although it uses some of the same tools from traditional security practices, the problem is sufficiently different that we need to use very different techniques. And key management is one of the things that changes dramatically. And we've been working for some time on a new cryptographic technique, well, I guess it's not new anymore, called broadcast encryption. Now, broadcast encryption, I guess, was initially designed for a broadcast channel such as cable TV, but it really can be applied to stateless receivers. So it's a more generic concept than just cable TV. And it will provide, it has this, this nice behavior that only compliant devices will be able to decode the content. And because it doesn't require this handshake in traditional cryptography, such as, say, public key, first, it lends itself to very simple protocols, and it also to applications that wouldn't be possible with PKI, for those of you who are familiar with it. And also, because you can implement it just using symmetric encryption, it's orders of magnitude more efficient. Now, how does this work? Each device gets assigned a different set of keys. This is unlike other systems where there's a global secret in which, if that global secret gets compromised, then the whole system has been compromised. In this case, each device has its own key. And then there's something we call a key management block, which is sent with the content. A key management block is really just a data structure, and I'm going to talk about that in a minute. But really, its function is to enable this where only compliant devices will be able to recover the key. So what a key management is really a multiple encodings of the same key. The purpose is for me to send a subset of you a key. And I want all of you to end up with the same key at the end. But I want to be able to exclude some who, for example, I don't trust. So that's the problem. Let me walk you through one very trivial algorithm. This, of course, is not practical, but it works. It follows this restriction. So if I'm a device, I have a key, and I know, so I can send, I know what my key is, and I know what my position in this vector is. So I can send a key management block, which has the encoding of KM, this management key that I want to send to everyone, and it's encrypted multiple times with different device keys. So if I'm device A, I know this key, I can decrypt KM. And if I'm device B, I know this other key. I wouldn't be able to decrypt this, but I can decrypt this. Now this happens to be an encryption with a different key of the same KM. So both A and B end up with KM.
Okay, so when you're saying that somebody has multiple devices, is the idea of this that one person has multiple devices, you want them to give him permission to use the content on any of his devices, he sends you, say, the public key of each of the devices, and then you send them back a table of encrypted keys?
No, the way this is set up is slightly different. The way this is set up is you start with generating keys for all the devices that you want to participate. Right?
Okay. Now these devices, they have what's the equivalent of a public key, and in an RSA?
No, it's all symmetric. So I generate a key, and I give it to you. I generate a different key, I give it to you, and so forth. So now each of you have a different symmetric key, right?
Yeah,
and that's your own personal key.
Yeah, okay. But if I get somebody else's key, I can use it if it's symmetric.
Sure. But that's
So.
let me address that in a minute. But the goal is for me to send you, and you this other key. So what I do is I encrypt it multiple times. Once for you, once for him, once for which is what this represents. Now, if I have reasons to believe that you've given your key, you've posted your key on the internet, for example, and now I know that your key has been compromised, and that there may be a lot of people using your key, what I want to be able to do is to prevent you and all the clones created from your key to compute KM.
Okay. Now, why do it that way, where with a symmetric key, when, if these three devices give you a symmetric key, you can post it on the internet. If instead it was the public key and nobody else, and you have to really get in and dig in and be the determined guy to get the private key, and you do the same thing, you pass back the same table, but it's based on public keys. Now the publication of somebody's public key doesn't give it to everybody.
Right. That's possible. One of the reasons we've been with use this is that it's truly one way. And for example, when you have media, when you're distributing this on media, then you don't have the ability to have this handshake, right? Because one part is the player, and the other part is a dumb piece of media. So it cannot compute.
Okay.
So what this allows us to do is to use that. Now, it's possible to build a broadcast encryption system using public keys, which is, I think, where you were going.
Yeah.
And it's in the art, and some people have done it. And in the systems that we've built so far, we haven't had a need for that.
Okay, until somebody broadcasts his key.
Okay, so let's say somebody does broadcast their key.
Yeah.
What I want to be able to do in this system is to be able to prevent that key from being used in the future.
Oh, okay. So that's all you buys you. It doesn't buy you protection for those things that have already been.
Correct.
Okay.
Usually, we don't care about things that have already been compromised, because if somebody hacked into the content, they probably ripped it and made it available in unprotected form already. So you want to be able to renew going forward. So the way we...
Can I ask a question about that? If somebody has already copied your contents illegally and they've already posted it on a public website, what's your recourse? You don't know that.
Well, that is not a key management issue, but there are other techniques that can be used potentially for that. For example, what you can do is you can trace that this used to be copyrighted, or that this is copyrighted material and used to be protected. And the technique that's used for that is watermarks. Of course, watermarks have their own technical challenges. And that's why I said, really, when you build a system, you can't really focus on one aspect, say, just the key management, and ignore everything else. Mm-hmm. It all kind of has to come together.
So you're going to disable this on a future, say, playing device, as opposed to...
Pardon me?
I'm trying to figure out how you're going to disable this. You're going to disable this on future playing devices as opposed to the current media.
Well, what we want to do is we want to, when I distribute new media, I'm going to distribute it with a new KMB, a new key management block. And what I want to make sure is that none of the devices that I already know have been compromised can play that new media. That's my objective. Okay? So, again, if they insert an old piece of media with an old key management block, they will be able to play that content. There's no way for me to recall media. So in this very simple case, the best way to prevent, say, device B from accessing the content is to
well, I guess sound effects work.
Add garbage there. That's very simple. Now, of course, the problem we have is if we want to handle, say, 1 billion devices, which is probably pretty reasonable, now we have this of
Lots of garbage.
1 billion times, 64 bits for the key. So that's a lot of data. So that's why I say this is functionally complete, but very impractical. So what we've done in a system that you can, that's incorporated in players and media that you can go out and buy today, is we've used a matrix as opposed to a one-dimensional vector. And the products I'm referring to are, for example, DVD audio, which is the new format for premium content, for premium audio content. It's multi-channel, higher frequency rate, higher everything. It's protected with a system called CPPM. It's content protection for pre-recorded media, which is a close relative to CPRM, which is for recordable media. So this is something that's already been implemented, and it's currently commercially available, and it's working. And okay, before I dive into this, is there interest in understanding how this works, or should I just?
Yeah, sure.
Okay. How are we doing on?
You're fine.
Okay. So now, instead of just giving one device key to each device, we have a matrix of keys, and we give one key from each column. And of course, there's the combinatorial advantage to this, because now with I can use a much smaller matrix to accommodate a much larger device set. So think of the matrix as this. Now device A will have
What's bouncing? Yeah.
That's the exercise room.
So it's not an earthquake.
When you say each device, you don't mean if I have the same model and you have the same model, those are two different devices of single manufacturer?
If we have two different, okay, I need to turn this off.
Shoot it.
Driving me nuts. Sorry. Should have done it before the meeting.
Don't feel bad. I was at a meeting where the president of Stanford University was making a presentation, and in the middle of a sentence, his pocket started to sound off. So, but he could hand it to his wife.
So, no, each individual device would have a different combination.
Like embedded in firmware.
Yes.
It would also be keyed into the serial number race.
No, it doesn't have to be.
It doesn't have to be, but it would be in the book somewhere.
So now, if we have two different devices, device A and device B, device A is going to get all the green squares, and device B all the red squares. And there's a chance, there's a probability